Welcome to I for Science. Good day everyone! Today we have our special guest Mr.Charles with us again. As you may remember, he's our test subject and has been put through a lot. Here in Sweden it's very cold now, so we figured out that it would be a good idea to do an experiment with fire. So, today we're going to show you a violent reaction using aluminum powder and iron oxide, which is the red powder in the glass container. This reaction is called thermite. By using a sparkler as a fuse, we have time to remove ourselves to a safe distance. As you can see, the thermite reaction is very hot, melting the glass and Mr.Charles alike. Even after a couple of minutes we had to use snow to cool it down. The reaction reached a temperature of about 2500 Kelvin. And that's no surprise. Under Charles is a lump of molten iron which has gone straight through him. And it's still too hot to touch, so we put him in more snow so he could cool down. Well, now that he's cold you can see the result of our little experiment, and it's quite devastating. But you might wonder what happened, so we're going to explain it to you, as usual. The thermite reaction you saw is really a simple redox reaction between two metals. The iron coming from the iron oxide is reduced, while the aluminum is oxidized according to this formula. To start this exothermic reaction we need to add energy to overcome the activation enthalpy. To ignite the thermite we therefore used sparklers because they burn well, seeing as they have their own oxidizer contained within them. This is important because the magnesium ribbons we used first couldn't start the reaction, because they stopped burning as soon as they reached the thermite since they lost their source of oxygen. So this is what is referred to as thermite. We've hoped you learned something about redox reactions today, and we will be back soon. And remember to keep your eyes open for science. Goodbye everyone. Chloride, and the flame now burns with a greenish color. What we have showed you today are the basics.